A second type of frequency distribution is called a grouped frequency distribution. And with this group frequency distribution, we're going to be looking at quantitative data. So this is numerical data that we can perform calculations with. And what we're going to do is put them into groups. And the reason we do this is you'll learn this if you take a stats class, it's continuous type of data. So we have infinite possibilities for what the data value could be, but we want to group them so that we say, oh, there's 10 that fall within this range of values. For example, if we wanted to list the weights of, say, 100 different people and then draw some conclusions about their weight, we would weigh each one of them. And depending upon how accurate we wanted to be, we could weigh to the nearest pound, we could weigh to the nearest tenth of the pound, hundredth of a pound, etc. And then we might end up with 100 totally different weights. And so we then class them and we say, well, let's create classes of weights. So we'll say, how many people weighed between 100 and 119 pounds? How many are between 120, 139 pounds, and so on and so forth. And then it's kind of grouping them by similar characteristic. In fact, if you look at a BMI, a body mass index chart to determine if you're overweight or underweight, etc., that is a grouping of, it's a grouped data distribution. So one of the issues here is, well, what do we do with 119.8? Where would that go? Should we round that up and put it into 120, or should we do something else? And what I'm going to propose is that we should really think about these classes as not being 100. We should really write them this way, 100 to 120, where we include the lower limit, which is the smaller number on it, and we don't include the upper limit. So that means we can get infinitely close to 120 but not include it. Instead of writing 119, we put 120 not inclusive. So then the next class we would write 120 with a bracket, meaning any number that's 120 goes in this class, and then up to, we're going to say the next one looks like it should be 140, but the 140 doesn't go in this class, it would go into the next one. So under this scheme, to me, it's very obvious where 119.8 goes. It would go right here because it's between the 100 and up to, but not including the 120. Now, our author argues that what you could do is instead of, if we didn't round to a whole number and we rounded to a decimal place, we would put 100 to 119.9, but that's exactly what's happened here. This goes all the way up to right up next to 120, because what if we had 119.98? Where would that one go under this new strategy? With this one, to me, it's very clear where everything goes. But maybe not. My brain's wired mathematically. You all let me or your instructor know if that isn't very clear, and we can talk it through during our live sessions. Okay, so here's how we construct a group frequency distribution. These are kind of the steps to go through, and we're going to follow our textbook, or our author takes us through a problem to create this. So refer back to this. I'm going to flip over, and here's our data set. These are the high temperatures for each of the 50 states, and the data is in degrees Fahrenheit. So if you think about what's happened here, we've grouped by state, although it's not really grouping. So we have 50 data values of all their heights. And then 5 is an interesting question. Why would a categorical frequency distribution be a bad idea? Well, the categories are going to be states, most likely, and then it has been categorically distributed. So we're only going to have one data value for each state. We could group by geographic region, but that just gets difficult. Okay, so here's what we want to do. We want to say how far apart are the largest and smallest values in the data set. That means we're going to find the largest one. This is step 1 from our thing above, and the smallest value, and subtract them. So it's unfortunate that this is listed alphabetized by state. Typically what we would do is list these data values from smallest to largest, and it makes this process much easier. So I need to find the largest data value in the data set. So in this column, the largest number is 134. So I'm going to look in the next column and see, is there a number larger than 134 in here? I do not see a number larger than 134. And then I'll do the same thing in the next column. Is there something larger than 134? There's not. And then in the last column, all right, so to me, the largest value is 134. Now I look for the smallest number. So I'll look in the first column and say, what is the smallest number? And it's 100. Is there a smaller number in the next column? Nope. How about in the next one? Nope. And in the last one, no. So my smallest number is 100. And to figure out how far apart these are, there are 34 degrees between the largest number and the smallest number, if we keep track of the units. That's step one. Step two would be pick a specific amount of classes that you want to create and divide this by the number of classes. So our author says, well, let's pick 15 classes and see what happens when we divide. Is that going to be an appropriate amount of classes to divvy up this data set? So when I divide this, I get a number that's about 2.267 degrees apart. And I don't think this is a good idea because there's only 2 degrees difference between each class. So we're not really going to get a good look at how spread out the data are, or kind of like what are the most common high temperatures, etc. And if you think about how many data values we have, there's 50, and we're distributing those 50 data values into 15 different classes, we're not really going to get a better idea of what's happening with this data. So our author knew that. He wanted us to experience choosing a bad amount of classes. And so he says, repeat this, ignore that one, and let's use 7 classes. What does that look like? So 34 divided by 7 is 4.857. So Arthur says, why did I choose 7? Well, do we really have an idea? If you look at this, it's a number really close to 5 if we rounded this up to the nearest whole number. And 5 is a wonderful number to add and subtract by. The other thing we could think about is we're taking the 50 data values and distributing them between 7 different classes. So each class could, if they're evenly distributed, have, or uniformly distributed, have 7 different values in it. So it might get us a better idea of what's going on with these high temperatures. Okay, so step 2 of finding the class width, you're supposed to divide the range values, so the 34 degrees by the number we chose, and then round up to get the class width. So this 5 degrees represents the class width. In other words, that's the difference between the upper and lower limits. Okay, so then we're going to decide the lower limit for the first class. That's step 3. The smallest data value is often a great choice. And in our case, the smallest data value was this 100. And so that's a multiple of 5, which makes it a wonderful number to add 5 to. So I'll do lower limit here, and we're going to list those lower limits. Then I'll do upper limit here, and then we're going to group all our data in there. So if we make 100 our first lower limit, then the next lower limit, kind of ignoring his strategy, is going to be adding 5 to this, which would be 105. And then we'd add 5 to that one, we'd get 110, add 5 to that one, we get 115 and 120. 1, 2, 3, 4, 5, 6, 7. Here's our 7 classes. So I just added 5 to each lower limit. Now, what he says to do is to subtract 1 from this, and that would become the upper limit. But what I think is a better, it's really what you should do, is actually put in 105 here, and you put a parentheses on it, meaning we don't include that one. We don't put 105 in this class, we put it in here. So these would all be brackets, and these would all be parentheses. Yes, I did that one right. So what would the one be here? Well, if I had continued the lower limits, I would have added 5 to 130, so I would get 135 here. All right, now our job is to go through our data set and get the frequency. So we have to ask ourselves, how many of the numbers in this data set are between 100 and 105, not including 105? So we have to go through and count, and this is ridiculously tedious. I'm just going to go through the first class, and then I'm going to pause the video, put this in Excel, and let Excel do it for me real quickly. I might even show you how I did that. So I'll go through and count. Here's a number between 100 and 105. So there's 1, nope, 2, nope, 105 doesn't count. It goes in the next class. Nope, 3. So I get 3 values in that first class. I could continue this process, but it's kind of tedious doing it here. So let me set up the Excel worksheet, and I'll show you how that makes it really easy to do it. Okay, so I entered all of my data values into Excel. So I see I have 50 data values. I'm going to make these a little bit larger so we can actually see what's going on. And then Excel has this really nice feature where you go over to this sort, and we're going to sort from smallest to largest. So now I can very quickly see how many numbers are between each of our classes. So if you remember, our first class was 100 to 105. That's these 3 numbers. Our next class was 105 up to 110, not including 110. So we can do a little, Excel has a little function in here. It's called count. And so I can go from 105 up to 109, and this will spit out that there were 8 values in there. So it counted it for me. So we'll do the next one. Equals count again, and then I'm going to go from 110 all the way up to my upper bound in this class was 115, and I can't include 115. So there's my count. Here, hit enter. That was 16 data values. I'll do the same thing. Equals count one more time. And the next class starts at 115 and ends at 120, not including 120. So that would be up to 119. And there's that one. Hit enter. What was it? It was 13 data values in there. And then my next class is 120 to 125. So I'll do my equals count here. And it starts at 120 and goes up to 125, not including 125. So there are 7 data values there. And then 125 to 30, there's 1 data value. And 30 to 135, there's 1 data value here. And, oh, I'm wrong. 125 to 130, there's 2 data values right there. And then 130 to 135, there is 1 data value. So let me double check that I did this right. Based on what I have on my table, these are the frequencies for each class, and I just want to make sure that they add up to 50. So I'm going to do sum of all those and make sure we have 50. Oh, glory days, we've done it correctly. Or at least the numbers add up to 50. So let me show you what my table looks like. Oops, I didn't have that set up right. There it is. So each of my classes, the lower limit, the upper limit, and then how many of each there were. Now, you don't have to know how to do that Excel thing. That was just a shortcut. And in reality, when we give you exams, we're not going to make you go through this tedious thing. But I think it's helpful for you to see how these distributions are created. It helps understand how they